Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here's information about online seminars and study manuals for exams P, FM, IFM, and LTAM that I offer. I direct the Actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. An insurance company sells automobile liability and collision insurance. Let X denote the percentage of liability policies that will be renewed at the end of their terms, and Y the percentage of collision policies that will be renewed at the end of their terms. X and Y have the joint cumulative distribution function, f sub xy of xy equal to xy times the quantity x plus y, and the whole thing divided by 2 million. For x between 0 and 100, and y between 0 and 100. Calculate the variance of x. And here's the solution. So we find the cumulative distribution function of x by taking the limit as y goes to infinity of the joint cumulative distribution function. But of course, the only values of x and y in both cases are between 0 and 100. So the function, the cumulative distribution function, reaches that limit when y already goes to 100. And you get that limit by just plugging in 100 for y in the cumulative distribution function formula, joint cumulative distribution function formula. And you can see this here. And this becomes x times 100, but that 100 cancels with 2 million, and 2 million becomes 20,000 when it's divided by 100, times x plus 100. Once we know this, we know that the survival function is 1 minus that. And we use the Darth-Vader rule to calculate the expected value. It's the integral from 0 to 100 of the survival function, because the random variable is non-negative with probability 1. So we can use the Darth-Vader rule. That's equal to 1 over 20,000 times the integral from 0 to 100 of 20,000 minus 100x minus x squared dx. That's 1 over 20,000 times, that integral is 20,000x minus 50x squared minus 1/3 x cubed, evaluated from x equal to 0 to x equal to 100. Of course, the value at 0 is 0, so we only need to calculate the value at 100. And 20,000 times 100 divided by 20,000 is just 100. 50 times 100 squared divided by 20,000 is the second term with a minus sign. And then 3 times 20,000 is 60,000. So the third term is minus 100 cubed over 60,000. This is approximately 58.33. Well, we can't really use the Darth-Vader rule for the second moment, but what we're going to do is just find the density as a derivative of the cumulative distribution function. So derivative with respect to x of x times x plus 100 over 20,000. And that's equal to 2x plus 100 over 20,000, which is x plus 50 over 10,000. And then we use this density to find the second moment, so that we can find the variance. The second moment is equal to the integral from 0 to 100 of x squared times the density of x plus 50 over 10,000 dx. So it's 1 over 10,000 times the integral from 0 to 100 of x cubed plus 50x squared dx. And, the integral of x cubed is 1/4 x to the 4th, so 4 times 10,000 gives us 40,000. We evaluated from 0 to 100, the value at 0 is 0, so it doesn't matter. And the value at 100 is of x to the 4th is 100 to the 4th. plus 50x squared. Well, the integral of x squared is 1/3 x cubed, so 3 times 10,000 will give us 30,000. And x cubed at 100 is equal to 100 cubed. So it's 100 cubed times 50 over 30,000. And this is approximately 4166.67. And the variance is this second moment, 4166.67, approximately, minus the mean squared, so 58.33 squared, and this is approximately 763.89, and that's answer A. Please remember this is copyrighted material. The problem itself belongs to the Society of Actuaries. The solution is mine. Good luck in your studies and good luck on the test.